Greetings, everyone. Welcome to our educational session of the USDTL ToxTime presentation. I am thrilled to be your host today, Jenny Olivos. In today's ToxTime, we are honored to have Dr. Donna Coy joining us. Together, we will delve into a compelling topic of psilocin use testing with USDTL. Dr. Donna Coy is a laboratory director for USDTL with over 10 years of experience in the forensic toxicology field. Dr. Coy is a certified toxicologist chemist through the National Registry of Certified Chemists and currently serves on the board of the Midwest Association for Toxicology and Therapeutic Drug Monitoring. Dr. Coy has co-authored several peer-reviewed scientific articles and qualified as an expert witness in over 200 family and civil court proceedings. Please note that opinions presented in this session are those of the presenter and do not reflect any official policy or position of USDTL. We have a lot of attendees today, so we will try to answer the questions that are most relevant to the presenter's expertise during our limited Q&A time. Some part of the presentation will be interactive with poll questions that will appear on your screen. So with the first poll question, which name do you use when discussing psilocin? All right, so with that being said, hand this off to the event to Dr. Coy.
All right, thank you, Jenny. Thank you for the kind introduction. And we'll get started with my presentation today. Okay, so first off, what are magic mushrooms? I'm sure you hear magic mushroom, shrooms, psilocybin, psilocin, and a whole host of other street names for psilocybin, which is a hallucinogen. So first, if we talk a bit about the history of magic mushrooms, psilocybin comes from the mushroom genus Psilocybe. It's estimated that there are over 144 psilocybe species that contain psilocybin and up to another 60 species of mushrooms that also contain psilocybin. These mushrooms are pantropical, so they're found in Mexico, Canada, the US, Europe, Asia, Africa, and Australia. These are generally dark spored mushrooms that are gilled, so they have like ribs under the cap of the mushroom. And they were first isolated by Albert Hofmann in 1957, and he also first synthesized psilocybin in 1958. There were some clinical studies after this discovery, but the US did classify psilocybin as a Schedule I drug in 1970. Psilocybin has a strong history of use recreationally, spiritually, through shaman rituals, and medically. Indigenous and tribal communities have used psilocybin for centuries. Central America has shown evidence of mushroom worship that dates back to 1000 BC. And this picture depicts some examples of 200 stone mushrooms that were found in Guatemala. And these are dated back to as much as 3,000 years old. So what does psilocybin use look like today in the United States? Every year, SAMHSA comes out with a national survey on drug use and health, an annual report. So I don't believe we have 2024 yet, but these are statistics from 2023. So this is use in the past year, age 12 or older, and you can see that marijuana remains the top use, which has been trending for years now. But hallucinogens come up next, and this category includes LSD, PCP, peyote, mescaline, ecstasy, ketamine, DMT, salvia, and also the psilocybin mushrooms. The highest reported use is in the age group of 18 to 25 years old, with a 6.7% of people using in that group, which equates to 2.3 million people in the US. Psilocybin is used recreationally for psychoactive effects that have been described as mind expanding, deeply emotional, and even spiritual. They can cause an altered perception, an altered state of consciousness, and they can be emotionally intense. So in the wrong setting, someone could trigger anxiety or have difficult experiences, which could lead to a bad trip. So again, psilocybin or mushrooms are a Schedule I drug in the US. They can be consumed dried, fresh, or as extracts. Mushroom edibles and teas are also popular. And in general, the mushroom contains about 0.5 to 1% psilocybin. The metabolite psilocin, which we'll be getting into later, can also be found in trace amounts, but is either not present or up to about 0.6% of the mushroom. We look at psilocybin in public health. Oregon was the first state to enact the Oregon Psilocybin Services Act of 2020. So this is the first law in the United States to establish a regulatory framework for receiving psilocybin treatment. And unlike medical or recreational marijuana, psilocybin can't be purchased and taken home. For personal consumption, it has to be used on site. So there's support before, during, and after administration by a licensed facilitator. The quantity someone consumes, their past experiences, and their expectations about how the experiences will go will affect their reaction. So right now, the US is looking at treatments for depression, anxiety, trauma, addiction, and for spiritual well-being for psilocybin uses. There is some evidence that psilocybin or psilocin rewire the brain. And by rewiring is really a simplified term to describe a very complex process. So the metabolite of psilocybin, which is psilocin, promotes neuroplasticity. This increases the growth of dendritic spines in the neurons. And these are structures that help transmit electric signals. Can also stimulate the formation of new connections and pathways in the brain. Psilocin disrupts the default mode network. This is where someone repetitively focuses on negative thoughts. And it's thought that psilocin reduces DMN to allow more interconnectivity, kind of like a reset of the brain. People have also said they have a greater sense of connectedness and emotional openness after using psilocybin. Effects can persist for weeks, months, or even longer. And if we talk a little bit about the metabolism and how psilocybin or psilocin work in the body. So mushrooms are consumed and they contain psilocybin, which is a prodrug for psilocin. So a prodrug is a biologically inactive compound that's metabolized in the body to an active compound. So in this case, psilocybin is our prodrug and psilocin is our active drug. Once it's ingested, the psilocybin travels through the stomach and intestines, and then it's metabolized in the liver by CYP P450 enzymes. These are enzymes that also metabolize other prescription or drugs of abuse. It's converted to psilocin and then transported to the brain via the bloodstream, and it acts on serotonin receptors in the brain. These areas include the prefrontal cortex and amygdala, and they're parts of the brain that affect mood, cognition, and perception. Once the psilocin has traveled through the body, it's going to be metabolized further and then excreted into mainly urine, but also fecal excretion. This is the chemical structures of psilocybin and psilocin. So once the liver metabolizes it, we have dephosphorylation of this group, and then we end up with a hydroxyl group, forming the active psilocin compound. So this is depicting just the similarities between psilocin and serotonin. So you can see that their structures are very similar. So psilocin acts in a similar way as serotonin. Serotonin is a neurotransmitter involved in mood, cognition, reward, and learning. as well as physiological processes, including vomiting and vasoconstriction. Serotonin regulates mood, appetite, and sleep. And there's several types of antidepressants that target serotonin, like SSRIs, which are selective serotonin reuptake inhibitors, which block reabsorption to elevate serotonin levels. So we can see how we're using SSRIs to treat depression and how psilocin might be able to be beneficial in that area as well. Although psilocybin treatment is being explored, again, in clinical trials, there's limited data on the pharmacokinetics, and the data that we do have is a wide range of dosing and types of subjects being used. So from mice and rats to humans and even pigs. So this is some data that's compiled from several different studies, and it's depicting the Tmax, or this is the time of the max concentration in the blood, and the Cmax, which is the highest concentration achieved in the blood after a dose, in a variety of subjects. You can see in this top graph, we're looking at the Tmax, and our top two here are humans, oral dosing, and IV. So you can see our time to max concentration range from about 1.5 to 4 hours. They also have rat and mice data here. And then for concentration, or Cmax, in humans orally, for blood levels, they're quite low. This is psilocybin in a urine sample, Cmax, up to 800. And then human IV, and then we have some mouse, rat, and pig data. So you can see that there's kind of varying concentrations between different species and dosing. If we look at psilocin, this data was acquired from several studies on the max concentrations of psilocin over time. And this data trends the same as the psilocybin data, with peak psilocin concentrations hitting around 4 hours in oral dosing. So most of these graphs here are 0 to 5 hours, and you can see we're getting our peak concentrations. Let's see if I was over here, in that kind of 4-hour range after dosing. The top left graph here is an IV dose of psilocin, so we can see a quick decrease in concentrations, indicative of a pretty short half-life for psilocin. So what are the effects we see after taking magic mushrooms or shrooms or psilocybin? We can see tachycardia, dilated pupils, restlessness or arousal, euphoria, hallucinations, synesthesia, which is hearing colors or seeing sounds. We have increased body temperature, headache, sweating, and chills. And these effects can occur within 30 minutes and generally last for about 4 to 6 hours. A bad trip may include unpleasant hallucinations, anxiety, paranoia, or panic. Another compound that we test for here at USDTL and urine is Bufotinine, and this is an isomer of psilocin. You can see here that they look very similar, just with these two hydroxyl groups in a different position. And again, Bufotinine is an isomer of psilocin. It is a hallucinogen, and it's found in mushrooms, plants, and toads. It has also occasionally been found to naturally occur in trace amounts in humans. And in general, the Bufotinine has a less desired reaction recreationally. So most people describe it as less pleasant than other hallucinogens, and also has more physical side effects that make it less favorable. And many times Bufotinine could be confused with other toad-derived hallucinogens like DMT. So just some information about psilocin detection in urine. The half-life of psilocin is about 1 to 4 hours, and that makes our urine detection window quite short, generally about 24 hours. You could potentially get out to 48 hours if you have higher dosing. but we do have a shorter window of detection for psilocin in urine compared to other drugs. Our current cutoff that we're using at USDTL is 10 nanogram per mil. We don't know a whole lot about urine concentrations of psilocin, but there was a study or a paper that summarized some studies earlier this year that showed urine concentrations after dosing between 50 and 2,000 nanograms per mil. In general, psilocin is an unstable compound, so we need to protect it from heat and from light. And that's because of this hydroxyl group that's in the 4 position that's circled here in red. So this makes psilocin a phenol, and phenols are prone to oxidation when exposed to air, light, or heat. So it oxidizes rapidly in the presence of oxygen and also in alkaline or basic conditions. So for psilocin, we need to treat it very specially if we want to be able to detect it in urine and not get degradation of the compound. So for collection here at USDTL, we have our collection instructions on our website. This is just an example of the urine collection kit that we show there. Some of you may be more familiar with the smaller urine cups that have the white screw tops, but any urine container can be used. So you're going to do your urine collections the same as you would with any other testing, with a couple of additional steps. To protect the samples from heat and light, we want to wrap the specimen container in aluminum foil. So this step you want to do after you've already sealed that specimen container. And then you want to ship it with a cool pack in some sort of insulated container, whether that be a box that's insulated or an insulated pouch that you can ship in a box or a FedEx bag. This is an example of a portion of our chain of custody forms or requisition forms for urine testing. So you can see psilocin is not indicated in the panels here. So if you'd like to add that test on for a sample, you're going to go ahead and just write psilocin here in your add-on, and we'll make sure to get that tested for you. And then just to reiterate for the collection instructions, you're going to collect normal procedure. You're going to wrap the specimen container in foil after sealing the specimen. Ship in an insulated container with a cool pack. And then we will reject specimens if they're not wrapped in foil or they're not in that cool pack. So if either of those are not fulfilled, we will reject that specimen for psilocin testing. However, if you had checked other testing, say a 10 or a 15 panel, we'll go ahead with that, with testing those other drugs. So that's all I have for you today.
Subscribe to our channel and visit our website for more information.